Okay, let's talk about aqueducts. We remember the big idea with an aqueduct is to get water from here and bring it here. It's a very complicated process. The basic idea, though, is that we want to enslave gravity and make it do our bidding for us. We know that gravity is pulling everything down, so if we can make sure that the water starts at a high point, ends at a low point, gravity will do all the work for us, bringing it downhill. The problem is that we don't necessarily have convenient hills, which is why we build an aqueduct, which is basically a giant hill. It's a very controlled hill, though, which is kind of the trick here. So when we're building this, we want the aqueduct to have a very specific slope or gradient. And so the idea, if we remember, slope, thinking way back to Algebra 1, or perhaps thinking to earlier today when you were in Algebra 1, slope, we remember, is rise over run. So what does that have to do when we're talking about an aqueduct? Well, if we look, here is the rise kind of our aqueduct. Right? We have some vertical distance that it's covering. And in terms of the run, well, that's simply how far the aqueduct is going. And so when we're building this, in order to have a good steady flow of water, and we want a good steady flow of water, if we have a very fast flow of water, it could erode stuff, flood over the edge, sloshing a bit, we don't want that. If we don't have a steady enough flow, we might accidentally have it, we might get a hill somewhere, like if there's a bump. This would be bad, because then the water can't go over the bump unless we're put a ton of water, but then it's going to slosh again, and sloshing is not a good idea. Anyway, I digress. We want to have a very specific slope or gradient in order to ensure that we have a good controlled flow of water. So when in Rome, the standard prescription, as best as I can tell thanks to Wikipedia, was a slope that looked something like this. It was 1 to 4,800. So basically, this was our rise, or actually in this case, our fall. So you would fall 1 foot, let's say, for every 4,800 feet that you ran. So we go down 1 foot, and we go over, way over, continue going over, and probably a little bit more than that actually, because that's not quite 5,000. And this would be our our run. And so this is not terribly, probably should go a little further, not terribly practical for us to do out in the courtyard. So instead of going with a ratio of 1 to 4,800, which, to put this in perspective, this is roughly 1 foot to 1 mile. Non-ideal again. We're going to go with a slope that is going to be negative 1 over 50. Negative because, pause now for dramatic effect, answer in your own mind, unpause when you're ready to go. Because we're going down, right? This is going to have a negative slope as we descend. So we're going to go down 1 for every 50 we go over. So now the question then, is this in inches, is this in centimeters? That's actually a choice that we have. I would encourage you to use centimeters, as I am a scientist. But so this is kind of a prescription for what the aqueduct has to do. So when we go outside, we'll have this, serene kind of, here is my artist rendition of the courtyard. We'll have some tables. We'll have some ring stands. So the question that we need to answer is, where should these ring stands be? Because we need to make sure that we can put our gutters, and by gutters I mean our aqueduct, lying on top of these, except it doesn't have a bit in the middle. Lying on top of these so that we get a nice good flow of water, and so that the slope is a comfortable 1 to 50, or negative 150, down 1 over 50. Of course, then we have this other slight problem, right? I've been avoiding the elephant in the room because I realized I misspelt siphon earlier. Siphon actually spelled with an I. I'm sorry, siphon. It's not my intent to slight you. All right. Let's say that we have this giant chasm, massive chasm, giant big hole. which, you know, we couldn't possibly build a support over. It is way too far away from a reasonable height. If we built it down, it would have to easily be 2 or 3 ring stands tall, and that's just impossible, basically. So we're going to use this siphon, which is basically going to be a nice flexible thing that runs through this hole and means that we don't have to build such elaborate supports. So if we make this siphon, right, this has the problem where we got kind of the separated bit where there's not a thing here. So it is very important. This bit right here is tricky. If we don't get that position right, the whole thing is just going to go bottom up. So, to recap, we have an aqueduct. The whole purpose of an aqueduct is to bring water from, you know, a high source, perhaps some pool, spring, or in our case, a bucket that has been placed at the top of a gutter. And it's supposed to take it and run it gently down. Let's make it a little less gently. Gently down to the other end, which in our case will be another bucket. We need to make sure that the slope of this is very carefully done so that it goes down the appropriate amount for the distance that it goes over. And we want to make sure that it, you know, works. So, what we're going to do is plan around this slope, that we're going to go down 1 inch, 1 centimeter, 1 foot, whatever we choose, for every 50 inches, 50 centimeters, 50 feet that we go over. So there's going to be a little worksheet to help plan this out and try to figure out where every point is and how far down we have to go. Because if we think about it, basically what we're trying to say is that this aqueduct, and here's the math people, so if this is going to make you cross-eyed, this would be a good spot to stop, take a deep breath, and regain yourself. The aqueduct basically looks like a line. And what we're trying to say is that this line has a slope of minus 1/50th. And we want to know, when we put these ring stands on, these ring stands are basically points on the line. We want to make sure that they all line up properly and are actually here. So, you know, we can figure out where, you know, basically what the X position of the ring stand should be and what the height, the Y position of the ring stand should be. And we got to do this for all of them to make sure that they are all appropriately placed. And I'm struggling to count to 4. It's been a long day, you know. Alright? And so the trick is, we can choose all of these. You know, we decide where we put the ring stands, just in some nice spot to hold the gutter. And then the thing we do have to figure out, though, is where the support goes. So this is what we control. Or what we have to, not what we control, this we have to get right. So we have to calculate this. These we choose. Alright? And so that is the challenge that presents ourselves, to figure out exactly where these should fall on the line. Good luck, Godspeed, and may we bring water to the end of this aqueduct chain thing. Rome? I don't know. Good luck.